didn't touch the HOD level. This is the way, sir, we are going to do this yellow belt session here.
So can you go back to your mapping?
Makigama.
Yeah. So what is this process, Mala?
Sir, one by one explain this small. This is the merchandising process for the AKL department. So,
who draw this, Maja?
Sir, Nasmul, Kadir sir, and Saurabh and the team.
Sir, with the merchant team and from the team, me, it's Saurabh Mondal. We have drawn this.
I not clear. Say it again. Who participate for the drawing?
Sir, there was Mr. Anand sir and some team leaders from merchandising department. We have arranged to sit together. Then we have draw this process mapping.
May I know who is talking there, please?
Sir, this is Saurabh Mondal.
So you're from the lean team?
Yes, sir. I'm from the lean team in Ekel side.
Okay. Who are the process owner was involved in this?
Sir, Mr. Nazmul Kadir sir.
Sorry?
Mr. Nazmul Kadir sir. Nazmul Kadir sir.
Okay, Nazmul. Fine. So Nazmul, after you joined this, what was your basic understanding?
Voice was breaking. Can you come again?
So what was your understanding once you mapped this session, or when you were with the session doing together with him? Hello? Can you hear it, Nazmul?
There's a problem with the network.
So he's no more in the connection.
Yeah.
So who are the other people who were in the process?
Is Enam connected? Enam? Saurabh, Enam ki connected?
Harry, just if you allow me, I can add.
Can you talk for a minute?
Yes, sir. Harry, just if you allow me, I can add my experience while mapping the process initially with Teresa and my champions, Ronnie and Enam. So, first of all, this is the way identified each and every process. Like from day 1 to day 90s, we used to call them like action or TNA. But in the process mapping, each and every action transformed into either documentations or inventory or process, quality gate, critical gates. So into these transformations, all these things happen, which is helping us to understand how many processes over there from day 1 to 90, how many documentations process over there from day 1 to 90. So after doing this, we have found there are some value-adding activities, there are some non-value-adding activities. Yeah. So our core objective for the process mapping, what we feel is to reduce the lead time, separating through ECRS. So that is my understanding, first of all. Then we have through the swim lane. streamline process mapping, we have seen right from sample department to store, every department is interconnected into the process through streamline process mapping. Whereas we can see through which we can see the functions and activities of each process for each day from day 1 to day 19. So total visibility is there. We can easily connect to each process, each other process, and we can eliminate the non-valuating things. We can reduce the lead time. And in terms of documentations against each day, you will be finding, like right from brief sheet to sample cut check, we have found a lot of improvements over there can be happening by the documentation process. There are some documentation which is not standard at all in terms of our the standard worksheet process mapping. It's under worksheet. So we are working on that to make the our documentation or standard worksheet as per the standard. So overall, it's like total visibility is there. Thank you, Harry. Sorry if I missed anything.
Sorry, Harry, I am back now.
Okay, go ahead.
So I think you were asking the main goal of the Makigami process mapping.
Yeah. So basically, what was your outcome? What were you trying to achieve through this whole exercise?
So we have done the initial mapping for first 35 days, keeping the main goal in So when we have gone through the hard copy Makigami chart, then we have instructed the lean team, okay, to relate these activities with the real-time style. Okay, so these all are hypothetical. Okay, so we have taken this. These are the process. These are the standard timeline. Blah blah blah. But what we will do now? We will connect this.
So you will connect this to actual one. That's what it says.
Exactly.
When do you think you are going to do that?
Within next week. So we have already started working on it. So we had a review meeting yesterday. Okay, so the instruction was given on that meeting.
Any plan of a date we are going to do?
We will close it before the Eid holiday, which is 19th of July.
Okay, that sounds good. So I'm connecting this to the note that Rokun yesterday raised on that weekly diagnosis cost of failure, right? Cost of failure that you all saw once a year, now you see on a weekly basis. So you don't have to wait till another 365 days to say that, guys, we have cost of. Now, when you had on a weekly basis the cost of failures, now we know how our process works, right? The main takeaway from this is cost failure happens. That means we have a standard budget to operate in the standard process to run. Somewhere down the line, that process and the budget is not working together. So you have a deviation, you have a red number. So when you have a red number, actually we are reacting to the situation. So what we can do now is, we can do two things. One, we can go back on that weekly budget to the daily budget and also work on the proactive manner. Now, if someone is asking or doing some work, they know in advance what are they supposed to do. Because if you have a weekly budget, that means there is a daily budget as well. So if there's a daily budget, that means daily budget prior to activation, you know, if I do this, I am going to crash it. So knowingly why are we going ahead unless there has been a corporate decision on that to say, no problem, we'll go ahead. So you need to now go back one step down. And then based on that information, you'll go and look at a process and map it and see on your big process where does that piece stays. So you can basically kill two birds out of this basically. One, you can bring back your cost into the same standard. Second, you have a target for the lead time reduction. So what you can do is you can work the lead time reduction as well. The more number of days you take to map it, action it, understand it, and see it, your lead time number of action days will increase. So I'm happy that you are keeping a deadline for the 19th, right? So we have to take the process mapping versus the numbers that Rukun shared yesterday. Take both together and have a correlation. Because the numbers would have seen at a high level, process mapping is also maybe at a high level. You can break it down to a minor level to understand where does it get connected, right? So I'm happy that there is few people being identified to do the training, but the role Himmel, Nazmul, all the senior leaders you all guys should do now is when there's a deviation, ask from your team, show the process. Which process did I deviate? Where did you deviate? Show me in your mapping. So if you don't kick that out, if you don't start that dialogue, process mapping will be a beautiful in the wall. I will have a lovely file maintained by the lead team, right? Numbers will keep being read at Rokun's table.
Yeah, Harry, what I was like discussing with Kashun and the team yesterday, like when we have done this like Makigami, so this is a beautiful page of paper, definitely, as you said, and the process has been mentioned like right place, right one. But like if we can do a sample of running 5 to 7 style on this process map, okay, like 5 style which has been executed, and we are having right, say as we are having the PCT date hit, those styles, if we can run within the process map, within the line, then we can get a real view of that. And based on that, like if there is any, like when I was going through, I have seen like some of the submission dates is been mentioned on day 7, which should not be mentioned on day 7. It should be mentioned on day 13. Okay. So these kind of small areas where we have some like viewpoint, like, or not viewpoint, sorry, where we have some limitations actually.
Yeah.
Some mistake we have done earlier. So when we will be running through some specific style on the line, I think we get a proper Makigami set in the place with the process flow. Once the process flow is set right, then only like we can start like giving input into that week by week, and we will get the right cost of failure or right events of failure that we are facing with.
Fine, no problem, Rokun. So they can start doing for the new style. But only thing, ensure that's been drawn by the process owners, not by the lean team. No point in their drawing it for you all. The process owners has to do that part, because the process and they are the people who are performing the KPI. They are the people who are giving you the result. So definitely they need to in the drawing, you understand the way it's been drawn and the challenges for drawing, right? So when you are looking from a, say at a 10,000 feet high level, the whole view, you know what question to ask. We might ask the wrong question from the process owners, and the process owners say, my God, now we have transparent our whole process. They might like to give the answers. So summarizely, so let's draw it for actual process right now and do it fast, because already we have gone about more than 45 to 50 days. SIFE has requested those quarterly, every quarter target. So if you really want to get that every quarterly target, we can't take about 45 to 50 days for the mapping to come out. So you have to start connecting the board together. Himel, you want to ask something?
Thank you, Hari. The thing is that still we are enjoying the lead time of 90 days or more than 90 days. And there are some customers and there are some gestures from the customers. Lead time is going to be shrinked, like down to 90 days, and which is our in process mapping. So if we calculate the process mapping, we have only 35 days which are in our control. That is our production lead time. And balance 55 to 60 days is mostly external, like procurements and all. So how we can just overcome the challenges with the external factors?
So what we do is external.
Yeah.
External, we need to break into two. There are externals within our control. So suppliers are in our control. Because they come for the organization, they come for the order, right? But from the customer perspective, we are not in the control because we go for them to unasked orders. There's two sides of the story.
Right.
So what? 2/3 we are in control, 1/3 we may not in control at this moment. But if we can control the 2/3 and go back to the customer and say, guys, this is what we have done. The 2/3 internal and the external from with the suppliers. Overall, to make the end customer satisfied, can we have a conversation? Are you willing to bring this? Because end of the day, it's the whole entire value chain business is going to grow. It's not only about Aman is going to grow on the business. And this is how we have gone about with certain customers in my previous job. And the order which was running for 24 days or 24 days of a lead time came down to, initially it was 60 days, then it came down to 40, then it came to 24, then it came to 60. And the order name was called Read and React. And it goes on a very speed pipeline. Right? So select few customers. We will also help you guys to do that process. Understand where you're most either from a price perspective or customer demand perspective or volume perspective. Understand one or two value chains, map it, and let's have a conversation. And let's break it. This is internal manufacturing. This is internal custom interface. This is external supplier. This is external customer. So let's break the problem and see how big is the problem that in 30 days or 25 days.
Thanks, Hari.
No worries. Okay. Kasun, so all in all, summarize is job is good. Let's map it the actual. You can see it.
Okay.
Done. Taranga, over to you.
Thank you, Harry. Thank you, Unifield Group, all team. Can you hear me? Is it audible to everyone?
Yeah, it's clear, loud and clear.
Thank you. Assalamualaikum. Good morning to everyone. It's glad to work and having a session, another session with you, and special for me. And the other thing is, of course, I have done so far three sessions, two sessions so far. So you will remember that I completed the A3 thinking and the meeting facilitation. That two things I completed early. So shall I share my PPT now?
Full screen.
Yeah. Okay. Can you see the PPT, the presentation?
Yeah.
Is it okay? Yeah. Okay. You know about what we are trying to complete the yellow belt training sessions, and so far what we're trying to explain and what we're trying to understand about the learning to see in how we calibrate our mind and thinking pattern to see waste and using the simple techniques and understand the lean basic lean fundamentals through this yellow belt session. So first of all, as you know that when you are starting with the sessions, we believe that we are the right team at the moment. And also you will have a book and a pen, and you can write down the important things. And also you are in a comfortable place and might be in your meeting place, in your training room, and it should be a place to keep your book and write down important notes. So other thing is keep your phone silent, and it's very important you are a little bit away from the day-to-day to get this, the good learning piece. So keep your attention to the session. And when it comes to the yellow belt syllabus, so you all remember that we are discussing this every time. So you can see the green area, the out of all 11, there are 11 topics under this yellow belt training session. And this the first thing, the introduction to lean and the 5S visual factory, this was done Kasun and the team internally. And the Gemba Kaizen and the process mapping, Makigami, swing lane, and A3 thinking and meeting facilitation. These things we have completed so far. And of course, glad to continue the next session today. That is basic problem solving tools and the quality management tools. And we are the next session will be in the lean simulation, and the rest of things we will communicate how and when it's happen. I think lean house we trying to see every day. It's also very good for our thinking pattern and everything. So lean house is our model. Model will be our whatever we are doing. It's trying to fruitful and complete this model. When you look at the basement of this lean house, it say the operation stability. That means whatever the current processes and how stable our processes, and based on in your right side, also we are trying to build our material flow stability in our left side. So that's we call the Jidoka and just in time. And once we build in this major two columns, of course we can reach our customer demand. That means best quality, lowest cost, and also the shortest lead time. We were talking about this short lead time also some few minutes ago. And very important whatever we are doing, and it's try to fulfill this our lean house requirement. Anyway, when you want to improve the level of this whatever area. So definitely what we want to do, we want to do continuous improvement. So how do we do the continuous improvement? We can't do continuous improvement with then we all have to do problems. That's the highly flexible, capable, highly motivated people. That's why we are putting in the center of this model. So the people who understand the problems and taking the continuous improvements and make this model stable. So understand very important this model. So then problem solving. When you talk about the problem solving, how do you do problem solving? That's the part we're trying to emphasize and get the learning today. So
Taranga, just go back one slide again for a minute.
Okay.
So Himel, you spoke about crushing the lead time. So you can see on the left side, we talk about just in time. The right side, you can see the name built-in quality. So if we have errors in your process, when you're flowing the material, you cannot do just in time, or you cannot do lead time reduction. That's the correlation it works.
Yeah. Yeah.
In order to do those two things, the stability what Taranga spoke is the base. From the stability is also from the base, and from the base, right? You can talk about this like the soil. That is your basic fundamental 5S, right? So for us to create that flow and continue, today's session is the starting point of the problem solving. To see the basic fundamental tools of problem solving, right? So this is where you're going to talk about this whole part of Jidoka, part of it. So today is starting point of it. So I hope it's connecting what we are trying to do. By whatever we are trying to do today will not solve your whole problem or whole solutions. You all will not get it. Today we are going to start the first base of seeing problems and analyzing problems. So keep that in mind. Okay. Okay. Move forward.
Yeah.
Thanks,
Thank you, Harry. So let's talk about the quality, the basic quality management tool. Right. The today's session, what is the learning outcome? So we will be able to understand the problem and also the which quality tool we are gonna use for particular problem. So that's we can understand once we complete the session what problem in what kind of a tool and which tool we can convenient and we are going to about the value of the quality management, the I say the value stream like that. We will get the understanding about these things at the end of the session. So then content is, these are the major chapters of the today's session and the quality management tool. And we are talking about these 7 quality tools. And next we'll talk about the values and the benefits of this quality management tool. Okay, right. We will talk about this history about the quality management tool. Once you look at this picture itself, you will be Dr. Haru Ishikawa. He is a Japanese professor and engineer at Tokyo University, and also we name his as a quality circle, the father of quality circle. I mean, he is the wonderful person, and that he identify a lot of quality tools here in the practicing in that time. He identified particular 7 quality tools and formulate, and it's connected. He identified introduced 7 quality tools during the Second World War and in the Japanese industrial training program. And because in after the 1945 in the critical situation, in that they training programs, and in other ways they identify this as statistical quality control tools, in other words. So that means we statistically we will identify the movements and variations and upper level, lower level, those things. Also, there are some of the characteristics. That's why they use this as a statistical quality control tool as well. So what is the beauty of this 7 quality tool is those are very fundamental tools. That means there's no difficulties to use this for any level of people in the organization. Even the management and the middle management and the floor level group leaders, team leaders also can use this the basic 7 these quality tools. So that is why there is user friendly and very basic. And also we don't want a much more comprehensive training to understand this quality management tools. Understand a very simple way, trying to explain and teach you about these all quality tools. And and also here is another very important characteristic is to we can see always in a graphical and statistical expression in there. So then we can easily identify the problem, where the problems and the size of the problem, and also then the process owners and the immediate superior and the management person immediately can see the deviation once we look at these 7 quality tools. So once you identify the problem, of course, it helps to identify and analyze. It helps to analyze the root cause. Mostly we are using mainly this quality management tool to identify the problem correctly. When you identify the problem correctly, of course, that's numbers, then information will help us to analyze the problem and dig into the detail and get to the right root cause. So here we highlight that this quality circle, once after the practice this all quality management techniques and tools, in future we will talk about this quality circle as well. This is a very simple technique, and the mostly in the manufacturing flow, group leader, team leader level, how they can use these 7 quality tools. That actually we have another topic about the quality circle. Quality circle, the front level, that means the first level, second level leaders can use this 7 quality tool during their quality circle activity. This quality circle activity will come in very soon once you practice this in a management level. So when you practice, you will realize, of course, there are very interesting and very effective tools is here. Then you're trying to give this knowledge to your down level people. So next level, like that. Then automatically everybody in the organization will start to practice this quality management tool. That, of course, it will come like we call like a quality circle activities, in other words. So this is a very important things in there will be a connectivity after this session. We will talk about later about how we comes to this quality circle in near future, right? So let's take about the problem now. Right, what I am taking the problem, all the techniques and tools we are using to identify and solving the problem. So let's need to teach you, and also it will very easy you all to understand when you are taking the one problem and common problem in the industry. Then we will connecting all these quality tools to particular in a right sequence, then you can easily understand all 7 quality tools. Okay, let's take a problem. Before take the problem, how we can derive, how we can understand the problem. Problem understand means before going to the problem, we must data. You know about the data. Data, if I talk about data are 2 different segments. There are 2 types of data we can see. You will know about the quantitative data. What do you mean by quantitative data? Quantitative data is we can count. Oh, there is a value is there. We can count. So that we call, another word is the discrete data. We can count and there's a value. For example, audit marks. When you take audit marks, this is, we'll take the whatever the audits. So the audit marks is 86, 83, 90. The point is continuous data. What do you mean continuous data? Just get another example. When you want to measure your trouser height, so it will vary. Some and taller person like that. It will be little bit slightly, maybe difference will be the example in the 50 inch to 60 inch. In between 50 inch to 60 inch, it will be vary, but there is a connectivity. There's a continuation of this number. That's called actually continuous data. So like that, we can identify something like, we'll take another example in our industry. So measurements in the waist measurement, leg measurements, everything is there is the given spec, and so that means continuous data is there. So I think you can understand what is quantitative. There are 2 type of data, quantitative and qualitative. Then we understood the what is quantitative data. That's, there are another 2 different types, the discrete data and continuous data. This is much more theoretical part that there's no much to understand. Keep in your mind, there are some kind of data, that's enough. So the other one is qualitative data. So qualitative data is what we feel. That means that become a statement or some word. Using these 5 sense, you can see, if somebody will ask to just look at that and what do you think about it? Oh, wonderful, very beautiful, like that. Then you can see in a different level. So you can rate it from 1 to 5. You know, Likert scale is like you can rate is from 1 to 5 ladder is there. So if you want to feel something, feeling, so good feeling. When you talk about the taste, that also same, good taste, bad taste, very like that. You can identify those like a qualitative data, not the quantitative data. Then, for example, here the customer feedback. When you want to understand the customer feedback after your product sale or service, product or service, you can ask, what do you think about our product? What do you think about the service? So this product. So he can say, I'm agree with this. I'm not agree. I'm strongly disagree. Oh, I'm strongly agree, like that. So it will come like this kind of a Likert scale. I think you heard about Likert scale, that the lowest interest is there, then giving the 0.1, and when it comes to agreed level, so it will increase 1 to 5 like this. So this is qualitative data. So I think you now understand what are the data types. But to understand the problem, data itself not enough. What do you want to do? So data is not showing the problem correctly. How do you use this data? Then we need to convert data into information. So how do we look at this opportunity. So you convert that into summarizing and visualizing and analyzing. You can summarize some set of data, and you can visualize sort of data, and also you can all these things. I think you will between this data and information. So here in the image, you can see the set of data. We can't get any sense. We can't get any idea about this because that is a set of data. That means running data. Somebody can say there's a set of data. So information level, then we can understand. Of course, there may be top 3, there may be bottom 3, there may be good trend, there may be bad trend, there may be some are very which is very more activities, which is what are the less and a progress and the warning. Sometimes when you look at the graph and line chart or pie chart, those things, we will identify the situation. Sometimes it's a good progress, sometimes giving them red notice. So immediately we are taking initiatives. So yes, Rakun, do you have a concern about the? Yes,
Yeah,
you can ask.
your voice is time and again breaking. Is it happening with me or like with all? Can you confirm from AGDL and AKL conference room? You are here.
Sir, in AGDL conference sound is pretty clear.
All right. Then what about AKL conference?
AGDL also clear, sir.
No, that it's my problem, my area problem. Okay, let me fix it. Sorry, Taranga, thank you.
Okay, shall I continue? Is it okay for
Yeah,
you,
yeah.
Rakun?
I'm not that.
Okay, right. Okay, I think still we are not jump into the problem. We trying to understand the problem. So I think everyone can understand what is data, what is qualitative, what the quantitative, and what are the information, and what is the difference between data and information so far, right? So
Taranga,
we are
give me a second. Go
okay,
back to the
Harry.
slide. AGDL conference. Can someone explain this to me in 1 minute?
If we want to deep drilling any kind of problem, then first we have to take the data for convert it into information. So firstly, if we are taking the data, then data should be 2 types, that is quantitative and qualitative. So if we want to quantitative data collect, then firstly we have to identify the numerical data and the discrete and the continuous, like audit marks, some like measurement of a garments, and qualitative data should be like descriptive data and involve 5 senses, like how we are feel, how we are see, how taste is this, and how we are hear and smell also. So this is usually customers' feedback. We can take this data from qualitative perspective. Every data should be converted into information for summarizing and visualizing and analyzing your ability.
We can't hear you.
Sir, is this okay, sir?
Now, okay, last 30 seconds was not clear. Okay. Repeat.
Okay. So who was that?
Sir, I'm live.
Good job.
Good job.
So you understand why is so important of the data part of it. We have been collecting last 8 months a lot of data, but if data is not being summarize it, visualize it, and analyze it, you cannot kick off problems in a nutshell. Okay. So whoever it is collecting data, ensure that we get into this mood, and this is why we are pushing that data synchronization project. Whatever you have information, we want people to see live then and there to be solved. Hope.
Yes, sir.
Yep, go ahead, Tarang.
Yeah, good understanding. Very good. I think, very simple way. Everyone, I think, I hope that everyone having the same understanding about this basic techniques, right? Then when we are coming to the problem, yeah, I'm taking the very common problem. So it's like the company name is AB Apparel Company. So FCA failures. We'll trying to understand the problem. When you talk about the FCA failures in 2019, it was 98%. But when you look at the current situation is deep down to 80%. So what's the difference? 18%. And what extent? The last 2 years. So here, very clear the problem statement. So what is the current state and what should be the standard and how far we are facing this problem and what's the gap between the current and standard. So, we are setting up the target as well. The FCA, we need to come back to the end of 2021, the 96%. So this is the problem statement. So problem will synergize effect to the entire organization. Sometimes when we are talking about one place, there is a problem. If we are not solving that problem in a particular time, it will rolling out and it will badly impact to the downstream process. Step by step, then the entire business impact will get not only 18%, it will more than the 18%. That is all the drop by the 30%. We'll say example is the total, the factory overall quality performance is dropped by 30%. This, I think we will take this problem and try to connect the management tool, the quality management tool, to identify the problem and solving this problem. Okay, right. The first quality management tool is check sheet. So what about the check sheet? Again, Dr. Kaoru Ishikawa is the founder of this check sheet, and he is the Japanese professor and engineer and the organizational theorist, and he is working the Tokyo University between his time 1950 to 1989. He this check sheet, and the main purpose of this check sheet is provide a structured way to collect data. That is a check sheet, very important. How do we use this check sheet? And then we can assess the situation of the particular process. That three things very important when you talk about the check sheet. It should be a very structured way to collect data. The second point is, through that we can understand the process situation. The third one is, it will help us to analyze the root cause. So then the check sheet, I show some check sheet relevant to the particular two example. One thing is the particular problem, what I explained about the FCA failures. So we know that is of course the quantitative data. Why I am saying like that? It's very clear number of FCA failures. We can value, there's a value, and there we can count how many FCA failures. So it will rank like this. You will get different classes like this between 80 to 85. How many FCA failures recorded? There are 60, and in between 86 to 90 marks, there are 22 audits are recorded. Likewise, we can see situation above the 96 to 100, that area, there are only 13 audit having a good pass rate. That percentage is 21.7. out of all these 60 audits, the 78.3% is below our target level, below the expected level. And also this kind of a chart we call as tally sheet. Why we are talking about a tally sheet? I think we all learned in our school time, this the bundle of the 5 bundles, like means you can see there are sticks like the 4 sticks in a one angle, then the cross the 5th one we are crossing in the other angle. This is the bundle of it. It means its value is 5. Then when you look at the first one, then there are 3 bundles, that means 15, and another one is there, then total is 16. Like that, we are using this tally marks to prepare this tally sheet. Then tally sheet, tally marks we are taking to the complete this kind of a check sheet. This is one example. There is other example for the customer response. We talk about that qualitative data about the customer response. That the Likert scale also we talk about much little bit about that part also. And the strong disagree, neutral, and agreed, and a strong agree, like that. So here also we use this tally marks. How many customers strongly disagree? How many customers disagree? How many customers giving okay, neutral level? Like that, we have the set of summary of the responses of each and every customers. So when you look at the total sheet, the problem sizes, you can understand that the strong disagree and disagrees, we should focus in that 2 area. That altogether, when you look at out of that 60 customers, that is all about the 70%. So look at this, when you having kind of a check sheet, you immediately you can get sense about the problem and the problem situation. So this is we call a check sheet. I think you already started certain level of check sheet implementation. So this one I took from Kasun. Happy to say that you already started this kind of a check sheet, and also we can see that tally marks also in a 5 sticks bundle tally marks also we can see there. So continue good practice, and also take whatever the learnings today and get this further improve. That is the feedback what I can give. So interesting. So check sheet, that's all about check sheet. Any concern, any question about the check sheet? Oh, it's very simple technique. Or anyone wants to ask any questions about the check sheet?
Sir, how we can use this check sheet for our execution part?
Execution, yeah, it will come later, definitely. I'll take him one by one this. Thank you for the questioning. We'll take that in going forward, and we'll having a right answer for it in when you look at the other quality tools. Okay, we'll move to the second quality tool is histogram. In word itself, it's saying that histo, that means history of information, history of data. We are calling this histogram. So who developed this histogram? Histogram invented by Carl Pearson, 1891. He was a mathematician in United Kingdom between his time 1857 to 1936. The main purpose of this histogram to build the frequency distribution and also get to know graphical presentation of the data set. That will give us more insight, more attraction to understand the problem. So when you look at the histogram from particular quantitative data, the same check sheet, I convert that into the histogram like this. You can understand that FCA failures, right? Then between 80 to 85, there are about 15 failures like that, then between 85 to 90 and like that, then I mark in a green the acceptable level audits only. So, and the qualitative data, there's another example. There's a customer feedback also. We can display in a histogram. So this is a Likert scale that won't disagree, neutral like that. So this is the first red area is showing the size of the problem. This is, I think, you will get better understanding than the checklist. When you put that checklist information into histogram, you will have a better idea about the problem and the potential size of the problem. So again, I'm showing here. So the criticalness of the particular problem. That means audit results is not satisfied 78.3. The other one is customer not satisfied 70%. This is the level of the problem. So I think histogram also very simple technique, and definitely there will be some doubts about the bar chart and the histogram. Because why we are talking about histogram, we have bar charts. And then I thought about we are not, in 7 qualities we are not talking about bar chart, but definitely you will have some doubts about why you want histogram. We have enough bar charts. So what is the, sometimes there are some small differences in bar charts and histogram. Can anyone explain about any idea about what's the difference between bar chart and histogram? Okay, I will share this. So you can Google even very simply understand this, what is the key differences of bar chart and histogram. Bar chart, of course, you can see that x-axis mainly is a categorical axis. That means whatever categories, when you talk about type of fruits, type of vegetable, type of class, type of cars, so whatever. So it will come in our x-axis. There's no interrelation with class 5 to class 6, class 6 to class 7. It's totally independent. That's why in this bar chart, you can see gaps between each and every column. There's a gap. And when you talk about the y-axis, always they're showing the number. And when it comes to the histogram in x-axis, you can see continuation of particular numbers. So, for example, the marks obtained here from 0 to 30, there is a relationship. But also we can categorize, we can classify into each and every classes, 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, like that. So even here, we have a number of students in the Y column. That means the number. So very simple. There's no hard and fast initiatives for this. If you want, better go with the bar chart. If you want, you can go with the histogram. There's no right or wrong critical decision. So you can take whatever most convenient. Most important thing is to identify the problem size of the problem itself. That is important. If I taking this into another angle, see the another picture I took to get the better understanding. Bar charts, yes, here showing the categories: China, USA, France, UK, India, like that. You can see the gaps between it. There's no relationship. There's a gap there, and there's no gaps in the number range in histogram. So I think that's why I show in the quality numbers. There's a relationship that we can use the histogram. If you want to build a kind of errors, defects about the garment, there's no interrelation. Sometimes you can use the bar chart, maybe like that when you want to display the different type of errors. If you want to highlight the FCA failures or AQL failures in different section, for section 1, section 2, section 3, section 4, like that, you can use a bar chart like that. You just get to understand about these two things. There's no hard or fast rule. It's in our journey, you can use whatever. And important is to understand this. There are two types of charts and all things in order to understand the problem correctly, right? When it comes to Pareto analysis, this is the third one. So the founder is Italian civil engineer, sociologist, economics, and philosopher, Mr. Wilfred Pareto, 1848 to 1923. So his time, and that's why, of course, we are using the Pareto analysis from his name itself. He interesting point is here. So he understood this. What is this Pareto efficiency? He understood the wealth situation in Italian people. The 80% of wealth in Italy belongs to about 20% of population. That means that whatever the money, wealth in the Italy, that is microeconomics part is here. So he understood that 80% of wealth is distributed between the 20% of population. So if you want to do something in economics, in particular in Italy, so we need to focus that 20% of people, and we can talk about how we can focus to get the different results. So focus this 20%. When you talk about the manufacturing organization, the manufacturing firm, industries, how we can use this Pareto efficiency. We need to focus 20% of the factors to attack 80% of the problem. This is, we know that the problem, the 80% of the problem we can solve when you focus 20% of potential causes. So if you focus the 20% of potential causes, when you solve in one by one that 20%, it's directly impact to the result, increments 80% increment in result. So that is the Pareto efficiency, Pareto theory. This is very, very interesting and very important in every manufacturing and industries. We can use this technique, and this theory always is important to understand the problem area. So we know about the Pareto analysis. Now we understood the FCA failures in this much, and customer feedback is in this level, and 70% failure, and FCA failures like 78.3. This is situation was in the last two check sheet and the histogram. Now we are coming to the third one, is Pareto analysis. We can't do Pareto analysis without next level data. So we know problem now clearly identified. Now we want to understand how do we make a Pareto analysis. So to make this Pareto analysis, we have to gather the next level information, next level data. What is next level data? Why FCA failures? FCA failures. What are the reasons behind this FCA failures? We'll take some of the error codes, some of the errors what we familiar, like a garment shape out and uncut threads and measurement out, open seam like that, then row and packing like that. I have taken some sort of good reasons here. So what we want to do with these error codes. So if status are not available, start gathering data into check sheet. Again, we are going back to first one is check sheet. Remember that check sheet, what we are doing is the categorical frequencies there. What are the categories? What are the occurrences, and how many times it's happened? Then what are the frequency? Oh, then of course, for this purpose also, before moving to the Pareto, summarize this data, garment shape out. Then I just show in the summary of data, the categorical check sheet. So we have a look at that, what we talk about the errors in the garment, how many defects captured during the audit time. And altogether, it's like a lot of defects is there, but the number of audits maybe we took as 60 audits. In 60 audit, there are 284 defects mentioned in the audit, all the audit. So what are the situation? The garment shape out, there are 82. Then open seam, there are 22, like that. The round packing 20 and uncut thread 76. These are normal common categories I have taken, so you can define and according to you what are the key errors in there, right? And this check sheet we are taking it to the next level now. This is the check sheet. You can't see any order easy. Now we are taking this into ascending order. What is mean ascending order? Like this. So categorical check sheet, now we convert into ascending order. What is the biggest one? The highest number of errors, that because of garment shape out is 82, then uncut thread 76, third one is measurement out 60, like that. Open seam 22. When it comes to the percentage, it's like 28%, 26%, 21, like that. Then cumulative percentage, you know that how to make the cumulative percentage. Once complete the presentation, I will share to how we do these things in Excel sheet. This is a very simple part of the calculation part. Anyway, I'll share that also after the session. And the cumulative percentage is like, you can understand this is collecting collecting the first one is 28.9, then 20.9 plus 26.8 equal to 55.6. Again, then 55.6 plus 21.1, it becomes 76.8, like that. Then cumulative percentage will come up to 100%. This chart we need to set up for draw the Pareto. So remember that first we get the check sheet and make it ascending order. And let's make a Pareto analysis. So this is the same summary in my left side. This summary we are taking into graph. This graph we are showing the Pareto. When you making the Pareto analysis, first you do bar chart. Like categorical bar chart, you can see the shape out, uncut thread, like that. The ascending order, you can see the last kind of a sequence here. The first is the biggest one, then the second, third, like that. There's an order step down approach. So after that, there is a third axis in this, that is especially of this Pareto analysis. You can see x-axis, y-axis, and another axis in the right side. That's showing this cumulative percentage, 0 to 100. Then we are taking this cumulative percentage into line chart. So you can see the line is going from left to right, starting from 28.9, then 55.6, then the 76.8, like that. So it's going like this. Then think about our theory of particular analysis. The Pareto efficiency means 80% of the effect, impact, the 20%, the 20% of the causes impact to 80% of the problem or effect. That's why we are starting to make a draw from 80%. We are starting to draw an arrow, and an arrow from the 80% line. You can see the red line here, starting from 80%. Then we are making that until we meet the line chart, the cumulative percentage. When it comes, it's meet in between the third and fourth bars. So next step is getting down where it can be touched in the x-axis. Then we can see there are very specific two areas. So because critical few problems in the left side, and there are a lot of small problem in right side. We call this area the vital few. I showing in the red color because this is a vital few, very important few factors. We know this badly, this is effect to 80% of our total impact of the problem. 81. If you solve this vital few, we can improve our problem by 80%. I think you can get it easy. This is the vital few area. The other one is tribal many. If you have time, once you complete and once you reduce this first three vital few, then of course tribal many, you can focus the tribal many as well. It's not saying that this not impact to the final effect. Of course, even the tribal many items also impact to this another 20%, because 80% will increase by focusing these three vital few. What are those? Shape out, uncut threads, measurement out. Focus these big three problems always. When you summarize your information in your industry, your flow, so you can think about what are the main three categories, three problems in the flow in terms of efficiency. So take it out and immediately solve this vital few. It will help you to increase the problem by 80%. When it's analyzed again and again, this whatever the tribal many bars will come in forward, and it will come next time vital few. So once you complete the vital few, you can find another vital few. That is continuous improvement. Continuously do this, then automatically your numbers is getting higher. It's very, very important. Very interesting. This Pareto analysis. Start to practice. You will see the lot of opportunities to improve the process. And here I just trying to make a small assumption, because as you know, everyone know that in industry we don't have much more information after this. If you ask YFCA failures, people will give this categorical information like what are the defects and how many defects. If I ask about any more detail about garment shape out, there are 82 in this incident. As you can see, garment shape out, there are 82. If I ask from the responsible person, can you categorize this 82 shape out in another way? That means shape out in leg side, shape out in the bottom, shape out in front, shape out in leg, shape out in leg, like that. If somebody can categorize this garment shape out into another step, do it and use that tally sheet and the tally sheet again, control sheet, check sheet. Use check sheet and bar chart. Again, come to this Pareto again and again. I'm saying here, we don't have next level values or numbers. That's an assumption. I make assumption here. When you jump into the next step, this is very important too, because we don't have data hereafter. So what we want to do, if we don't have data, we are going to the brainstorming, right? Anyone have a question about so far? This we have come to the third.
Yes, Taranga. Just allow me 2-3 minutes here. I would like to get more clarified from the team AGTL conference room. Can anyone explain this page in Bangla?
First of all, sir, আমরা যে ডাটাগুলো কালেক্ট করতেছি প্যারাডো অ্যানালাইসিসে, সেটা হচ্ছে যে আমরা প্রতিদিনের যে ডিফেক্ট গুলো আছে, সাধারণত গার্মেন্টস যে ডিফেক্ট গুলো হয়, যেরকম এটার ক্যাটাগরাইজ করা আছে আমাদের 32 থেকে 38। সো এই 38 কাইন্ডস অফ ডিফেক্ট গুলোকে আমরা কোন এরিয়াতে, কোন জায়গায়, কোন ধরনের, প্রত্যেকটাকেই আমরা ওইভাবে ইন্ডিভিজুয়াল মানে টালি করা হয় র মেটাল থেকে, র ডাটা থেকে নেওয়ার পরে ওটা আবারকে আমরা সামারাইজ করে এটা প্যাট্রো অ্যানালাইসিসে সহ টপ 3 লেভেলে কোনটা আসছে, 4 এ কোনটা আসছে, 5 এ কোনটা আসছে, এভাবে করে 38 পয়েন্ট পর্যন্ত এটা বাই চার্ট বা বার চার্ট করা হয়। বার চার্ট করার পরে আমরা ওইগুলোর উপরে ফোকাস করি যে কোনটাকে আমাদের এখন অ্যাটাক করা দরকার, এবং টপ 3, আইদার টপ 4 আইদার টপ 5, এভাবে আমরা এটাকে কন্ট্রোল নিয়ে আসি। এবং এটা প্রত্যেকটাই ডাটা আমাদের কাছে এই প্যারাটিও অ্যানালাইসিস করেই করা আছে এবং সবগুলা সুন্দর মতো স্টাইল ওয়াইজ, বায়ার ওয়াইজ এবং যে কোনো ভাবে প্রত্যেকটা অ্যাঙ্গেল থেকেই এই ডাটাগুলো আমাদের কাছে সংরক্ষিত আছে এবং সুন্দরভাবে আছে, এভাবেই আছে।
Thank you, Ali sir. Great. Yes, over to Taranga.
Yeah, thank you. Now we are going to the fourth one. Before moving to the fourth quality tools, in between that we are talking about brainstorming, because we don't have data to going in detail to identify the root cause. What the next step is to do brainstorming. So brainstorming will come between our problem solving process, not the first, but not the end. In between the steps, we need to do a brainstorming, because we have data. Until data end, we don't want brainstorming. After brainstorming, also a lot of ideas is there. So that is not the end. We need to continue to identify the root cause. So in between the improvement process, we are facing this brainstorming step. So Mr. Alex.
Taranga, give me a second. The
Okay.
key message for the quality team and the production team: if you come across a defect, if you want to solve that defect, don't sit in a room and ask people why this defect is coming. So that is the message is Taranga is trying to give you very clearly. Your step number 1 and 2 is collect your data in sufficient and go to the location, right? Because if you go straight into the brainstorming model, right, you are going to tell a few people's assumption. Even for the custom interface, even for HR, it's the same. That is what he want to emphasize it. Why are we telling that is because generally we see when you see a problem, you call 4 or 5 people into a room and ask them what happened, what is your opinion, what are you trying to do, how are you trying to do. So that's not your first question to ask, right? That could be your last question to ask. Your first question is, okay, the problem, can I see the data? Then can I go and see it? Can I validate it? So make sure that. So if you guys have been practicing brainstorming, I want you to slow down the brainstorming to the latter part of the conversation. So that's the message Taranga wants to give. Okay, yeah. Move forward, brother.
Yeah. That's very clear. If you have data, go with data. Don't use brainstorming. Right. Mr. Alex Fakney Osborne is the American advertising executive. He is the person is found in this brainstorming technique. It's mentioned in his book is How to Think Up. This is the author of this book, and the main purpose is to of this brainstorming is to group finding solution. That means causes. Maybe we are asking for the one small focus area to finding more causes for the particular problem, and we are giving we are asking for the people, a set of people, to come and give you freely ideas what might be the causes for the particular effect. So that means that's about the brainstorming, and I'll just share about the important things in the brainstorming. While we are doing, we should understand the vital few reasons of FCPL. This example I'm taking this: the garment shape out, uncut edge, and the measurement out of tolerance. So these are the 3 big problems we identify through all the informations and whatever we have done so far. So take one by one to do a brainstorming. Don't do brainstorming for the entire factory. We can't do brainstorming for the particular operation area. It's not sufficient. It's not satisfied. That means if you are taking the brainstorming for the entire production area, why efficiency drop, why quality fail, then it is too far. It's too far. The boundaries and the scope is very high. Then people are giving lots of idea. It's not focus. So when you're doing the brainstorming, give the segment very focus area. Step then people will focus very freely only particular area only. So that's why actually Harry explained about don't use this in the big area. So you understand where is the problematic area and give people to focus in a particular segment only. Then you can have the very effective ideas for the particular matter. That's very important, right? So when you are doing the problem, the brainstorming, there are some set of simple principle is there because we should respect each other. When you are doing the brainstorming, the person who conducting, he should give the direction what for we are going to do this brainstorming. For example, uncut thread. We are going to talk about uncut threads. That is the focus, the direction. And he always keep the people in the stay focused in a particular topic. People are moving to the different part of the different causes, different effects. So you have to just guide them, and okay, we now again I am reminding you all, we are talking about uncut thread. Give the causes what you feel mainly for the uncut thread focus only. So then I involve everyone. That's also important. So whoever we are collecting, it's a 1 to 10, you can ask from first person to last person, or you can start from last person to first person, or you can start from left to right, right to left. Like that, you have to give equal opportunity to everyone to give their idea about the what he feel about particular effect or problem. So invite wild ideas. What do you mean that? So whatever idea, maybe the bad ideas become a good idea. The marvelous and innovative idea, it might be an innovative idea. So don't block it and ask, invite for the whatever kind of idea. It's everything should be welcome. For looking for obvious, think about that. Focus real situation in this, then automatically the ideas will come for the particular focus only. So cross-fertilize means actually when you talk about one person can give the idea and another person can add some more and give another idea, the advanced idea. So another person can add some more to the previous idea. The third person can give another good idea. So all three ideas will come, and all three ideas we can write down in the brainstorming time. And suspend judgment. In this situation, we are not talking about the quality of this particular ideas. We are collecting only. We are not talking, we are not describe, we are not going in detail about each and every point. Just we write down the ideas of each person and allow repetition. Sometimes the same thing another person also can say, doesn't matter. You can just mark it as a repetition, that's all. And don't stop. That means, of course, when you are giving the first round, second round, third round, if you want more information, more data, more ideas, you can go another round. Like that, you can increase the quantity, not the quality. You can increase the quantity of ideas. That's its mean, right? And the display ideas. Every idea should be noted in somewhere. In sometimes you can use sticky note, or sometimes you can use flip chart. These things you can use for record all the ideas. This is how basically the brainstorming happen. Once you do a brainstorming, just share with us. And the time you are doing the brainstorming, that we can share about your learnings in future for the in our next few sessions, right? Then we can come to the cause effect diagram. Again, we can remind this the Dr. Ishikawa is the founder of this cause effect analysis. You know, Ishikawa, we are talking about this his name, and the main purpose of this cause effect diagram to break down the causes into different segments, main segments, then it is easy us to understand which area having the more problems in a particular effect. So the purpose, with the purpose, we will jump into this cause effect analysis. So you can see here. Okay, you can see here what is the effect here. The garment shape out is the effect. That's the problem. Then problem we can break into whatever the causes that people have given through the brainstorming session. We have a list of ideas has gathered from the brainstorming session. After the brainstorming, you can categorize this all the things into main segments, like what are the problems coming from method side, what are the problems coming from material side, what are the problems coming from people side, and the machine side. If you want, you can increase the branches further, like you can use the information management system and measurements, like that. There's no hard and fast. You can increase the number of branches even here. So it's like a fish, and there's a head of fish in front, and the other area like the bone of the fish. So that's why we call another name is a fish bone. In the name is cause effect. Then we are in this Ishikawa diagram. Sometimes we are using fish bone. In some books, I have seen that the Fishikawa, fish and Ishikawa combined. Then another name I saw in the Fishikawa. So anyway, mostly we are using fishbone diagram. So information, now we got to know that what are the key branches of the causes. So here we showing that the garment shape out is the Y equal to effect and X equal to each type of causes. These all kind of each and every causes can impact in some extent to this final effect. We can't say what's the level. So what we want to do is we need to validate all these things step by step. What are the most potential causes out of these all the idea? So idea, a lot of idea, but we can't implement all the things at once. We need to identify what are the big potentials out of all this. How do we do that? So important thing is the validate causes. There are a lot of causes here. How we can validate? First of all, we trying to find out numbers. If there are any information regarding for each and everything. Here we can see a trimming, then the given amount in the method branch, and the measuring round methods, and machine and panel handling weaknesses, and poor of inline and inline quality assurance, like that kind of a method side. So anyway, what we want to do is how can we summarize this information? First of all, we need to look at how to validate each and every. If we have numbers, information, go with that number and identify what are the most impactable items is there. If numbers is not available, you can use visual data. Sometimes all these things we don't have number. As a team, you can walk towards a process and look at the informations, whatever the available in wall and information in the computer, wherever. So you, as a team, you can go and look at the second one, the visual data. And of course, sometimes numbers is there, but when you look at the visually, the numbers are not correct. So sometimes you can validate numbers when you are go and see in the visual data. Through the visual data, you can even validate the numerical data, as well as you can get some idea about how can we get the best out of this through this visual data. Even though visual data, you can't find the visual data, go and talk with the people, in the right people at the right place. That's very important, and asking the right questions from the people then we can summarize and cut off some minor things and take forward one maximum 3 items from this fishbone diagram. For example, I'm taking from here to the next step the trimming than given amount. Sometimes the machine is trimming than the spec level. And the next thing is the cut panel uneven. It's the material side. I mentioned here the X2, the cut panel uneven. Something like that. Through this methodology, that means cost validation methodology, first go the numbers, then go and see visually. If visual not available, you can talk with people. And when you talk, go to the right place and asking for the right person. And asking right questions, and sometimes you can give the good advice and the feedback to the process people also, and summarize what are the important 1 to 3 maximum out of this fishbone. So that 3 things maximum, take it forward to solve and identify the root cause. Then it will solve, by solving the 3 things, it will support to the final the garment shape out, the improvement of the garment shape out level. That's of course the fishbone. This one actually I'm taking forward, that's X1, because we need to understand the other set of quality management tools. We are taking this trimming, and sometimes we call this trimming, uneven trimming from the machine. Maybe during the sewing operation, uneven trimming will happen. That will badly affect to this garment shape out. I'll take in this method course, take it forward to understand the other quality tools, right? So this is a scatter diagram. When you talk about a scatter diagram, the founder is originally developed by the René Descartes. Sometimes the pronunciation might be different. So he is the French philosopher, mathematician, and scientist. Invented the analytical geometrics between his time. And the main purpose is this scatter diagram to understand the relationship between 2 variables. I'll take back again to the fishbone diagram. Can you see what the 2 variables here? So garment shape out, it's the effect. And we picked one cause from the fishbone diagram, X1. It's a trimming, uneven trimming, or trimming than the given amount. These are the 2 variables. So we need to verify whether this, what we make a decision is correct or wrong. That means we need to look at the relationship between this garment shape out and uneven trimming. Is there any positive relationship? Is there any negative, or is there no relationship? For that purpose, we need to go to the scatter diagram. Okay. So scatter diagram, sometimes we are using a different angle in the manufacturing flow. When you ask quality person, the inline quality person to mark the problematic area in the garment or sketch of the garment, then sometime giving some 1 or 2 days production, she or he will update the errors like this. So you can see most of errors has come in the fly panel of this boxer. So some small errors is you can see in a different areas of the garment. But when you look at the most potential area, we can see the relationship between this garment shape out and the leg fly panel uneven trimming in the leg fly panel area. That is the connectivity of physical things and this theoretical part. So this way we can practice in the production flow, we'll using the sketch and asking them to just mark the most problematic area in the garment. Then we can easily we can connect this causes to the final effect. Sometimes it will affect to the garment shape out. It will affect to the measurements like that. So then we can understand the relationship between these two variables. That's important. Then I will taking way mathematically how we can display this in a chart. So this the table you can get some idea about. That table is showing that uneven trimming 5 out of 10 garments. When you're asking to do 10 garments, the first day might be the second day, sometimes the first hour, sometimes the second hour, maybe you can use in whatever way, hourly basis or daily basis. Garment shape out, we take 10 garments. Out of 10 garments, there are 5 garments uneven trimming, like that. Then another set of garments, then the 6 garments. Out of 6, there are 3 uneven trimming. So likewise, we have to collect this data. Once we collect this data, we can drop into the graph like this. What is the, how can you understand this graph now? Here, the x-axis, we can see the uneven trimming. The y-axis, we can just shape out of the garment, right? Then taking more garments, it's showing the uneven trimming garment also getting increased. So there's a relationship, positive relationship. Both are increasing based on the quantity. If we talk about the shape out garment, it's getting increased, then uneven trimming also getting increased. There's a positive relationship between these two. That means if we focus uneven trimming, automatically we can reduce the shape out garment. If we focus uneven trimming process and where it's really happened, it will support us to improve the failure of shape out garment. I think that is important. That is the beauty of this scatter diagram, to understand relationship. Then of course we can take forward to the next step, going to after the scatter diagram. We are taking this, I'll mention here the high positive relationship between garment shape out and unevenness, uneven trimming in ply panel area. So we trying to understand the relationship between this and taking this problem forward. The next tool is flowcharts and process map. Then I will talk about this flowcharts. Flowchart, of course, we certain time we learn this flowchart in a different level flowcharts. Sometimes the type of flowchart you can see in the left side, the material value stream, high level mapping. This also kind of flowcharts, value stream mapping. You heard about, sometime you started already. And the type of flow, the next point is information value stream, Makigami analysis, swing lanes. These things come in under the information value stream. The process map, we now talking about the process map flow level. In the production flow level, how can you understand in detail level of the process, we are using process map. And people value stream, human value stream, like that, different level of values, process flows we can identify. Here, particular this matter, what is the matter? Actually uneven trimming. Now we focus uneven trimming process, not the whole sewing area. So we know which is the operation and where start is sewing and we are going to end. The focus process, we mentioned here the focus process, very important that word. We don't want to touch a lot of area. We don't want to touch every area. So we need to focus where we want to focus. That's very important. So uneven trimming, how it comes. Let's talk about this process. The pickup panel, align under the machine, sew to hole, then guide to the gauge and sew, and take the panel out, measurement and appearance. This is basically the team members is doing the major component, major steps of the sewing operation. So what we want to understand is, now we have to identify why this uneven trimming will happen, right? So we know that where this problem is available. That means where we can see the problem in this process at the last steps. That means check measurements and appearance. Then only we are getting know there is a problem in the operation. There are some uneven in the garment. So that is of course where we can identify the deviation. That's important. The point where we can look at the problem. Then we are talking about the where the problem really happened. We are going backwards. That's very important when you are focusing the problem. When once we identify where the problem is occurred, the problem is identified. That means check the measurements. During checking the measurements only we got to know. Then we are going backwards in the process and try to understand where these problems really happen. That is, of course, you can ask from there itself why this happened. That's why we mention here where the problem really happened, and here you should ask why to find the root cause. Now we has come to certain understanding about now again we will remind the big problem, audit failure, FCA failures. Then we summarize that the potential, the size of the failures, then what is the major errors, and after errors we are coming to the process level. Then process level, of course, we now draw this process step by step. Now we has come to the particular small area, that means most focus area is sewing operation. So here we can ask why to identify the cause. Then you can see identify the specific root cause and set countermeasure and execute as per the commitment. These things now you have to take into the action points. So here we identify the cause, then take the action points and put in the Gantt chart and follow the action point. This is important. Here only we have action points. So far we analyzed all the things, planning, understanding. So far we didn't do anything. We only analyze certain level. So now only we set up into the action chart and we try to initiate the actions one by one. So that is flow charts. So after flow chart, you have definitely you have action plan. Through action plan, take one by one initiatives with the timely manner. So that's the flow chart. When it comes to the analyzing progress, the last here I mentioned here the analyze progress. Once we initiate the initiatives, we don't know what happened to our previous problem. This problem is getting over, it will be fixed or it not fixed. How can we understand the situation and whatever the initiatives we have taken, it's how it was impact to our final result. That means garment shape out in particular thing. Then we can use the control chart. This is a 7 quality management tool is a control chart. Then the control charts invented by Walter A. Shewart, was an American physician and engineer and statisticians, and sometimes other of statistical quality control. You heard about that PDCA cycle, PDCA cycle, that's Shewart cycle. Sometimes we are Deming cycle, we are Edward Deming, and this Walter A. Shewart joined together and I think developed that problem solving cycle, PDCA cycle. That's called a Deming cycle, some Shewart cycle. That's why mentioned as the father of quality control. And the main purpose to identify the progress of 2 categories of variations. Now we know now we get the initiatives about the improvements for the particular causes in the last the 6th one. That means after the flow charts. So here what we want to do is validate the results. So you validate the results, you can use control charts. Here especially we focus special causes as well as common causes. Okay, right. We will talk about what special cause and common cause in the control chart. So here, how do you look at this control chart? Take one example here, check in 5 garments daily. Now we improve the process and we look forward how impact to the final effect. So taking 5 garments daily or taking 5 garments every hour, whatever way we can decide, and showing in the graph. And these graphical explanations, I'll tell you some kind of a new words is there. I mentioned here a spec, that the customer specification is measurements. USL, upper spec limit, you know, when you take the measurements in the measurement sheet in the tech pack, you can see the plus tolerance, minor tolerance, and the exact measurement, exact measurement. So then upper spec limit means that's a plus tolerance. Then a lower spec limit means minor tolerance. So you can now realize about the situation. And S1, S2, S3, S4, these are the samples which are selecting for check the measurements and look at the situation of the problem, whether it is solved or not. So S means average measurements of all 5 sample daily. We'll take the sample 5 garments, we'll say all 5 garments, what is the average value of measurement? That's basically we are saying S mean, sample mean. Okay, then this is the chart. We can make a kind of a chart. I mentioned here the day by day, and there are 5 samples, and you can see spec measurement, and you can see upper spec limit, and you can see lower spec limit, and sample mean. Sorry. Okay, I think this kind of a chart you can prepare if you having a problem with quality related problem. So likewise, so then after making this kind of a format, you can draw the control chart. This is control chart. For there are 2 control charts I selected here. So here the first this one, sample 1 measurement deviation. This every time I am taking the first sample only here, not the all 5 sample. One first garment we call the sample 1, and I mention here the measurements of each day first sample. What is the situation? So you can see upper spec limit and the lower spec limit in red color, and exact measurement what customer asks, that is in blue color, and the sample measurement is going fluctuate like this. This is this is how we mark these measurements in the control chart, right? The other one is I use this mean, sample mean. Again, I mentioned this upper spec limit and lower spec limit, and mean of what customers 8 cm, 8 centimeter, that the customers the measurement 8, and this the dark green color, you can see sample mean. That means what is the average number of out of 5 garments daily. So that's important because that represent all 5 garments. The first graph representing only first garment. That's important, right?
So give me a second, Taranga.
Okay.
So this particular document can be displayed for all your KPIs. So when you drew your trend lines for KPI, it's very important to draw the upper spec limit and lower spec limit, because when you say upper spec and lower spec limit, that is where you hit your customer or your stakeholder, the deviation. So at a glance, you see how the variation works. So ideal state is we need to work in between these lines here and here. That means we should work with less variation. Right now, when look at your data must be like this, going all over. So that means data is not in our control. So this is the importance of visualizing the information for us to find the root cause, for us to start doing problem solving. If the information is not available in that form, you can't attack it. Even for budgets, it's the same. Even for HR, it's the same, right? Even HR can do a fishbone to understand the root causes of why absenteeism, why on leave, why people leave, anything. Even the budgets, you can understand the same form. Thanks, Aranga.
Yeah, thank you, Harry. Okay, here I just want to explain, and this is so the some of the theoretical part, then the special courses. What are special courses? That means sometimes it's suddenly jumping from away from our control level. For example, you can see this point, the circle in blue circle. So this suddenly it has come to the away from the situation. That means, and the next one is you can see in the first graph, second cycle and the third cycle. This is going away from the control limit. That we need to look at any specific causes here. Of course, the first, not the first one, the second and third one is a very specific, because when you look at the 21st of June, it's showing above upper spec limit. Again, the next day, it's coming down again in the below the minus level. That means you can see from away from the above from the plus tolerance, it comes the next day the minus tolerance. So big jump is here. That means what kind of a special causes is here, not the process driven process level causes. Sometimes maybe it's a different things might be impact here. So we need to understand what are the special causes has happened to the particular day to the this garment, like that. So when you look at the second chart also, similar incidents we can see, right? The other one is a common causes. Common causes means it's showing in the red arrows. So common causes, we can see trends, continuous trend. That means system failure somewhere. For example, we'll say the thread tightness in the particular machine, continuously machine itself, it's getting tight day by day, getting tight, like that. Then automatically the impact is getting worse day by day in a one direction, right? Then we can look at there is something happen in the process. That's why this continuously getting lower. Sometimes the first graph also you can see the same situation, and another one you can see in the second graph, increasing trend is there. There are 4 to 5 points is increasing in one direction. It's giving some insight. Look at the process and what is continuously getting one direction. It should be the real way, means what you want to control our information, our measurements in between this per control and lower control limit. And it should be vary from plus side, minus side, plus side, minus side, not always in the upper spec limit side, not always in the lower spec limit side. It should be vary from the center line. That means blue line. One point can go above from the blue line, another day below, next day again above. Then there is no relationship. Then you can understand, okay, setup is good. Now measurements are managing between the mean line. So then the process is stable. we can happy about the process. So that's up to that level, we need to fine tune the process. Then focus the special cause and also common causes. Then continuously, there's no ending of this. Always you can find opportunity to improve in the process step by step. So that's all about the quality management tool. There is a relationship between this all 7 quality tools. So we start with the check sheet, remember, I think. Then we came to the histogram. Then we come to the Pareto, then fishbone, then scatter diagram, then flow chart, then we find out the root cause. Then we use control charts to look at the progress and how it works, like that. Then what we have done is narrow down the problem into the particular area and focus the root cause in a small area. So then it easy us to understand the root cause, and that's what actually we mentioned here, the narrow down the problem focus area in a systematic manner. This is, of course, we are not jumping to the control chart at once. We came in a step by step and narrow down the problem and find out where the right big focus area, where the right focus area, and cause identifications and control countermeasures, everything. So there is a systematic order, right? And here you can see in your right side, when you set up the improvement in the process, we need to hold it in a certain time and we need to sustain. The first standard you can see in this incline. So first standard is here. Then after that, what we want to do is we need to continue the improvements. That means we need to continue this problem solving cycles. You can see 2 standards and like that. There are 2 cycles is here. That means there's no ending of continuous improvement. So once you do continuous improvement, consolidate with the previous standard and a new standard. So set up the new standard. Again, we need to sustain the standard certain time, and automatically our quality standard getting increased. You can see in this the y-axis, quality standards getting improved. Again, we need to find what are the deviations. Again, we can continue this PDCA cycle. It is recurring. It's iterating the PDCA cycle and continue this journey. Then, of course, we can have a smooth and stable quality process and a stable material process. So that's all about the 7 quality tools, and what we want to do after the 7 quality practice. You now do this into your day-to-day activities to how can you initiate 7 quality tools. And next topic is we can talk about problem solving in a management level problem solving. So when you practice this 7 quality tools, so it will really help us to understand and do the management level problem solving. That means the recurrence problem continuously happen in the organization. So we can look at that number and take into this technique, the 8-step problem solving, and that really helps all the 7 quality tools to build this 8-step problem solving techniques as well. So in this 8-step problem solving, definitely all these 7 quality tools with inbuilt here. When you look at the step 2, I mentioned in a different color, the brown color, all brown color steps, definitely we have to use all these 7 quality tools. So when you look at the breakdown the problem, of course we must have tally sheet. We want to do the histogram, and like that. When you want to, then you talk about the root cause analysis, we need to do a fishbone and focus process map, and like that. Whatever the 7 quality tools really connected to this 8-step problem solving, and this will come later. First, what we want to do is practice the 7 quality tool, and this cycle also PDCA cycle, as I mentioned the early slide. This probably in the plan do check it. You can see up to the step 5 plan part. So here now today also we did a lot of planning focus. We did a lot of things, and the actions and the count. Check and adjust, it takes very short time, we can do that part. So that is the next step of the 7 quality tools. We will come to the 8-step problem solving in near future. And last but not least, and we talked about the benefit of the quality management. Of course, when you are doing all the things, we don't want to much emphasize these things, and you know about the 7 waste we can reduce the 7 waste. Not only material, human, energy, physical assets, everything we can save, and through this quality management. And once improve these quality practices, definitely efficiency will improve and quality will improve. And also when you're doing problem solving, definitely process improvement will happen. Then stable process will there, then productivity will get boosted. Once productivity getting increased means we can make happy customer, not only customer. What happened to the business and employees and stakeholders? So you can think about that's what we can take out of all these things. Once whatever things we are doing, first we practice, then only it comes to the organization, and organization can win the immediate customers and the stakeholders, and definitely then the business getting increased, your value and your earnings will increase. You can save your unwanted cost, you can reduce the cost. From that, earnings will increase, then employer getting more benefits. So that's the cycle. So this is the kind of benefits we can expect from practicing the quality techniques and quality tools. So that's all about things. Now, before moving to the activity, so we can talk about some 5 minutes. Almost now has passed the 10 minutes. But we plan to stop at the 12:30, now 12:40. Any questions? We can give very short time and discuss, and we can finish. Harry, over to you. Anything to add here?
Guys, any questions up to now? AKL, ADL?
Excuse me, sir. From AKL, I have a confusion about discrete and continuous data. Can you explain, sir? Continuous and discrete.
Okay, go back. Tarang, go to the slide quickly. Go back.
This
Put the
one.
full screen.
Yeah.
Go down, go down, go down, go down, go down.
Right.
So you asked 2 questions, right?
Yes, sir.
You asked what is
Discrete and content.
And continuous data.
Say it again.
Discrete and continuous data, I think, is that the question, right? The discrete data is showing the value and the counting. You can count how many like that. If you have we'll say whatever things like you can count the counting purpose, then you can count the coconut, you can orange or something fruit, so whatever kilos, something like that. Then here we mentioned the audit marks. The audit means is we can count, and there's a value is there. So that is actually the discrete data. So continuous data, there's no disconnectivity. So it is continue. That means like a measurement, we will take about the measurements. Sometimes it's a different, but there's a connectivity. That means we'll say 8 to 9. Somebody can say 8.1. And another person can say 8.2, and the person can say 8.3. There's a relationship between all these numbers. It is in one set of value. that is actually the continuous data is there.
So Taranga, so basically guys, continuous data has a range, right? So it has a range where you play around, but when you go to discrete data, it's a specific one number. Okay?
Yes, sir. Clear.
Right. Taranga, move forward to the last one before last slides. Move forward. Go to the PDC one.
Last one. Okay.
PDC one. Go next one. PDC. 34th one.
This one, no?
34. Go back. Oh, hold on. Go forward.
Wait.
Okay, hold, just keep it there. So the most important part on this is we need to continue. You can't, because right now the information, the data that we have in the organization, we have percentage allocated. 6% is okay, 3% is okay, 5% is okay, like that. But if you really want to improve a business, you cannot have the percentages, right? So you had to go in terms of quality, 1 in 100, 1 in million, 1 in 1,000 to level. So that even if you hit 100, don't ever think that you have completed your task, right? So our next question is, after you go to the 100, when you are getting your next defect, when are you getting the next defect? Are you allowing a percentage or are you waiting for a number? So the PDCA has to continue. So you can be happy when the numbers are improving, but that's very short term. Until you find the root cause, until you eliminate it, until you error-proof it, you have to continue. And this is a base to start built-in quality. This is a base. So in the future, we really want to see each process owner, not the lean team, are talking this, executing this, explaining this by themselves. And I don't want any lean team to talk about it, these tools in the future. They can teach, but when other people are presenting, the process owners, they have to talk in this language. So if you have any challenges of understanding the 7 quality tools, reach out, or will connect and will support us. Go to the next slide. Right. Now we have been talking about the 8-step problem solving for a long time. So hope you understand why we didn't teach you all 8-step problem solving until now, or we have not yet done. In order to do 8-step problem solving, there are 8 steps to be followed in problem solving to eliminate that problem. So our first step is developing the eye calibration, see waste. That's what we were pushing for last 18 months. But I'm yet to see the management, the behaviors, and the process owners walking the flow and eliminating the 7 waste number 1 before we start analyzing and solving problems. I'm yet to see that part. You all are doing it, but long way to go. Next is, based on that, your 5S will automatically improve. Once you have that both equation going into a next level, then you will see these quality tools applied and you will see a display or visuals how to analyze basic problems, very basic problems, and how you erase those things very fast. Because all the 7 quality tools is inbuilt in the 8-step problem solving. So if we don't practice the first one and the second one, we cannot do 8-step problem solving. So that means if we don't do waste, if we don't see the obvious, fix the obvious, as practitioners, as process owners, you can't manage 7 quality tools. So if you don't manage the 7 quality tools, doing 8-step problem solving is going to be a dream. And can you see the 8-step is breaking into 4 segments. You have a major planning piece, 60% planning, execution happening, DCA a little bit. So through diagnosis, we have lot data. So now what we need to do is we have to allocate time on a daily basis to do this activity. So I drop a note yesterday also to Rokun and the team, certain people were in that mail. If you think these activities, lean activities are for lean team, or to do once a week, or to do once in month, you will not get that quarter results. This needs to be practiced on a every day and every minute, whatever you see and whatever you do. So that is very, very important to keep that in mind. Move forward. So next slide. Okay, right. So your activity is going to be, we would like every process, every stakeholder or the process owner, go and revisit your KPI, identify some deviation, plot it into the 7 quality tools, see how you see it, share that information to us within next 2 weeks. Hasoon, not in 30 days, in 2 weeks. Any member is not giving you within 2 weeks, don't worry about it, leave them behind, move forward. Now we need to work faster. And we have information, so we have to work faster. So if you give it to me within 2 weeks, I can react fast. I don't like to use that word. I'm reacting fast. Ideally, we need to be proactive. But at this stage, we are going to react. So reacting also, I'm going to limit that space, limit that time period. So within 2 weeks, come up with every department, right? And Kasun, mark, if departments are not giving you the information, just mark as red, send the information. So then we understand who is supporting the Unifield Group operating system and who is not supporting the operating system. And as Saranga said on the previous slide, end of the day, this is for us. This is to improve the bottom line. This is to improve our performance, not to improve other person's performance. So Himel asked, outside is out of our control. Yes, but we are talking what is in our control right now. We have a lot in our control because our efficiency is at 60s. Quality levels at 87% to 90%. Cost of failure is we have a certain number. Overall, we have $1.3 million to hit by 2 years. So before we go external, we have plenty of internal. And we have got a department called production controlling team holding 7 days of stock. So I'm also now getting used to your numbers, your process. So that's why I can remember these things. So guys, lot to work, right? It's hard to remember, but I had to do a lot of homework to keep it remember. So I'm supporting 4 companies, but to keep remember all 4 are pretty hard. But that is the attention I'm working. So I am expecting the next 6 months your attention to detail. I don't have any personal grudge with anybody, but I'm driving a bit hard because process excellence is process excellence. No tolerance. Done. Sorry if I went a bit hard on the last minute, but it's not hard, but I'm convincing. I'm trying to tell you how it has to be done.
Thank you.
Team, can you someone can just explain the activity, please? So then we got to know that you right understanding about how to do this activity.
Other than Kasun.
Yeah. Somebody explain what are the
other than the lean team.
In your word, how do we do this activity?
Sarkar bolen to Sarkar.
Yeah, we are now trying to help Kasun and the team. Otherwise, there'll be big matters for them as well. So now we try to understand what is the what is the homework here. So the process owner, who are the process owner of the production or quality person or someone, just explain how do we do this?
So I am from AKL conference.
Yep.
So,
Yeah.
we have to follow first that 7-step procedure. So as per that, we have to data collection, identify the problem. First is identify the problem. Then we have to, as per problem, we have to collect data per check sheet. Then we have to make histogram. Then parallel analysis. Where is the problem? Biggest problem, 80% problem is there. So from there we can identify the measured 1 or 3 problems. Then we have to start this point, identify the problem, then select where to start and which quality tools.
Yeah.
That means we identified one problem, needle drop is there. So what are the major results there? Then with 3 identified, then as 3 point is there, so on we have to complete the root causes. Number 3. From identify, then we have to solve the root cause, complete the root cause for each. Then for each we have to set countermeasure, temporary countermeasure, or if possible, then permanent countermeasure. Then we have to report weekly basis, daily basis, then compare results. It is improving or not. If it is improved, then process is okay. Then we have to process, improve process. We have to tell our people that this process we have improved this way. So this we have to make them standardize the process.
Yeah.
That's
Yeah. Thank you very much for the. Mainly the identification, the problem, mostly if you don't have, you physically you can see the problem, but you can sometime you can summarize and you can really couldn't understand the problem size and the problem situation, then of course you have to start with the check sheet to identify the problem. Right. Okay. Thank you.
So from your end?
Sorry, sir?
Anything from your end, being the champion?
No, sir.
Fine. Rokun, over to you.
Thank you very much. Thank you, Taranga, for your all the philosophies and all the names that you have mentioned and all the processes. Because as an individual, a lot of us are with Pareto analysis, with the like concept that has been gone through today, but who was the inventor and how they managed to do that, it was not known to all. Like in our country, you will see, like my country people, like my fellow colleagues, you will understand, like if you are asking anybody after passing intermediate HSC, getting in like admitted into the university, they have given with 2 subjects of choice. One is philosophy, one is mathematics. Okay, the higher numbers will always go to the mathematics one, and philosophy will be coming to the lower numbers. But the world is ruled by the philosophers. Okay, so philosophy is very important. Okay, today's session was all basics actually, and a lot of I have seen the expression of the people. Why all these are coming again? Because it has been read, it has been gone through fishbone. We know more than enough. We are familiar with Hilsha fish. Okay, and Pareto analysis. We have done 7-8 Pareto analysis in all the projects that we are doing. But what is very important is to get back to the basic and fix the basics within the blood. Okay, within the culture. So this was all the slides. All 37 slides was very important. Okay, though it was very common to you, but it was important and needs to be cultivated within the culture and nurture those to get it better and better. And come back to the last slide of 8-step problem solving through PDCA. How we were we were listening this 8-step problem solving, see the obvious, fix the obvious. These all are like, it's on our lips. But how to do that, that has started being presented, and going forward, you will be getting better visibility of that. You are working very good. That is, there is no doubt, but there is always scope of challenging ourselves, where we are doing what and how that can be done better. Okay, so don't get tired, don't get bored, and don't get exhausted. You have miles to go along together, and all the very best. Thank you.
Thank you, Taranga. Thank you, Rokun.
Thank you, sir. Thank you, Taranga.
Thank you very much, Asun and all the teams members. Okay, see you once again in the next session. Thank you very much.